Okay, we move towards the machine structure, machine language, and assembly language. These three parts from the chapter first. So, what is the purpose of this concept of machine structure, machine language, and assembly language? So, the purpose of this concept to discuss machine structure, machine language, and assembly language with the example of IBM 360 or 370. Our purpose is not to teach a specific assembly language, but with this assembly language, we present enough material to show design of assemblers. ओके, आपण काय असेंब्ली लँग्वेज शिकणार नाही, पण असेंब्ली लँग्वेजची डिझाईन कशी केली आहे हे एक्झाम्पल मधून घेणार आहोत. द इंट्रोडक्शन ऑफ 370 असेंब्ली लँग्वेज ऑफर्डेड बाय आवर डिस्कशन should be supplemented by further reading. There are two base classes: the people who know the assembly language programming well and want to become the people. There are two classes of people: those who know the assembly programming language well. This is the first class of people who knows the assembly language, and second, the people who are familiar with 370 who have not programmed in assembly language. असेल सेकंड क्लास असा सेकंड वर्ग असा आहे की दुसरा वर्ग असा आहे की ज्यांना प्रोग्रामिंग लँग्वेज थोडीफार माहिती आहे पण त्यांनी स्टडी केलेलं नाही, आणि पहिला वर्ग असा आहे की ज्यांना असेंब्ली लँग्वेज व्यवस्थित माहिती आहे. So this is a general machine structure we have seen in previous lecture. So the main part of this structure is memory controller. This is the memory management, which have three main parts: memory controller, memory address register, memory buffer register. For that memory, there is connection of input output channels and other input output channels. Main basic input output channels such as mouse, keyboards, monitor. Other input channels such as printers, speakers, and other peripheral devices. Then this memory management connected with this CPU, central processing unit. This central processing unit have different registers such as location counter, instruction register, instruction interpreter, a writing register, that is working register, and general purpose register. So instruction interpreter is connected to the both working register and general purpose register, and the other CPUs, if any, connected to this memory management. This is one nuance of first computer, that is IBM System 360. We have studied this part in last lecture. So here in this general machine structure, here is the example. Add to 176. So here the operation is opcode, that is operation code, that is OP, then register number and a memory address. So this instruction add a 2 comma 176 would cause the data stored, this data stored at in memory location 176. Once here in this instruction 176 is a memory location to be added the current content at the general register 2. whatever जो काही डेटा आहे जनरल रजिस्टर 2 ला तो मेमरी ऍड्रेस 176 मध्ये ऍड करायचा आहे. दिस इज इन्स्ट्रक्शन फॉर ऍडिंग द कंटेंट्स at general register 2 and a memory location 176. And this resulting sum, whatever the result of this addition is done, is would be left as new content register 2. Whatever the data in register 2 after addition, that sum is stored at location register 2.
सर एक्सप्लेन करून सांगा की.
Okay, I will. Okay, see here the instruction written like this. Wait for a minute. समजा त्यांनी इन्स्ट्रक्शन दिलेली आहे आपल्याला ऍड रजिस्टर to then memory location here the given instruction is like 2 and then 176. So here add is the opcode operation code. Here 2 is a register number, then here 176 is a memory location. Okay, so जो काही डेटा आहे रजिस्टर 2 चा समजा डेटा आहे x, रजिस्टर 2 चा डेटा x आहे, मेमरी लोकेशनचा डेटा समजा y आहे, तर आपल्याला ऑपरेशन दिलंय ते ऍड दिलंय. सो व्हॉट एव्हर द डेटा in register 2 and memory location y, so add them. So here x plus y and the result is suppose z, result समजा z आला असेल. See here register 2 which contains the value initially is x, which contains the value initially x, but after this addition, after this addition the result z is stored at register 2. The result is stored at this register 2. This value x is removed and here new value is z. Did you get? तुम्हाला समजलंय?
हो.
Okay, then we move towards our PPT. So this instruction add to 176 would cause the data stored in memory location to be added to the current contents of general register 2. The resulting sum will be left new contents of register 2. Then the specific details vary. जे स्पेसिफिक डिटेल्स आहेत व्हॅरी फ्रॉम कॉम्प्युटर टू कॉम्प्युटर, मशीन टू मशीन, हे स्पेसिफिक डिटेल्स आहेत ते चेंज होत राहणार. दिस इज द एक्झाम्पल ऑफ मशीन स्ट्रक्चर respective to conventional machines. So what are the general approach regarding a new machine? नवीन मशीनच्या बाबतीत जनरल अप्रोच काय काय असू शकतात? एखादा तुम्ही नवीन मोबाईल घेणार आहात, तर नवीन मोबाईल घेताना तुम्ही काय काय फीचर्स बघणार त्याचे? त्याचा डिस्प्ले बघणार, त्याची रॅम रॉम साईज आणि मेन म्हणजे त्याची प्राइस, ह्या सगळ्या गोष्टी बघणार. सिमिलरली एखादी मशीन ज्यावेळेस कॉम्प्युटर तयार करणार आहे, तर नवीन ज्यावेळेस कॉम्प्युटर असणार आहे त्याच्यावेळेस त्याचे फीचर्स कुठले कुठले असू शकतात? तर मेमरी, रजिस्टर, डेटा स्टोरेज कॅपॅसिटी, त्याच्यानंतर instructions, how, then some special features. So we first list these questions, that is what are the questions. It consists of finding which questions are regarding memory, registers, data, instructions and special features. In case of memory, question may be like this: what is the memory's basic unit, size and addressing scheme? मेमरीचं बेसिक युनिट, त्याची साईज आणि त्याची ॲड्रेसिंग स्कीम कशी असू शकेल. इन केस ऑफ रजिस्टर्स, हाऊ मेनी रजिस्टर्स आर देअर, किती रजिस्टर आहेत. व्हॉट आर देअर साईज, फंक्शन अँड इंटर रिलेशनशिप, त्यांची साईज, त्याचे फंक्शन्स आणि त्यांचं इंटर रिलेशनशिप कसं असू शकतं. इन केस ऑफ डेटा, क्वेश्चन मे बी आस्क लाईक दिस: व्हॉट टाइप्स ऑफ डेटा कॅन बी हँडल्ड बाय कॉम्प्युटर, कोणत्या प्रकारचा डेटा कॉम्प्युटर हँडल करू शकतो. कॅन इट हँडल कॅरेक्टर्स, नंबर्स अँड लॉजिकल डेटा, तो कॅरेक्टर, नंबर, लॉजिकल डेटा हँडल करू शकतो. हाऊ इज दिस डेटा स्टोअर्ड, डेटा कशा प्रकारे स्टोअर केला जातो. देन instructions, what are the classes of instructions on the machine, मशीन वरती इन्स्ट्रक्शनचे क्लासेस कुठले कुठले असू शकतात. आर द अरिथमेटिक इन्स्ट्रक्शन्स, लॉजिकल इन्स्ट्रक्शन्स और सिम्बॉल मॅन्युप्युलेशन इन्स्ट्रक्शन, की ज्या इन्स्ट्रक्शन अशा असू शकतील का की अरिथमेटिक इन्स्ट्रक्शन असू शकतील का, लॉजिकल इन्स्ट्रक्शन असू शकतील का, सिम्बॉलिक फॉर्म मध्ये असू शकतील. त्यांचा फॉर्मॅट काय असू शकेल, व्हॉट आर देअर फॉर्मॅट्स अँड हाऊ दे आर स्टोअर्ड इन मेमरी, मेमरीमध्ये कशा प्रकारे स्टोअर केले जातात. अँड स्पेशल फीचर्स काय असू शकतील, तर व्हॉट आर द इंटरप्ट स्ट्रक्चर ऑफ द मशीन, इंटरप्ट स्ट्रक्चर मशीनचं कसं असू शकेल. व्हॉट सॉर्ट प्रोटेक्शन मेकॅनिझम इज अवेलेबल टू द युजर, युजरला सॉर्ट प्रोटेक्शन कसं अवेलेबल असू शकेल. सो whenever we are generating a new machine, the general approaches regarding a memory, a register, data, instruction, and some special features, we should know the answers of these questions. So this is the example of micro flowchart of add instruction. In previous example, add 2 and 176, this add instructions. So see here, machine address reader is less than equal to IC, that is instruction counter. If it is true, then flow goes to the next step, that is buffer, machine buffer register is less than equal to machine address register, that is read instruction from the memory. If it is true, then go to the next step. Then instruction register is less than equal to machine buffer reader. If it is true, then go to the next and test the instruction whether it should be add register, subtract, multiply, or other operations. In previous example, we have seen addition of a register and machine address or memory address, then add, that is first load the address, that is machine address buffer is less than instruction register, then data read in the form of machine buffer, then a write register, that is a register of instruction register of the register, that is the write register, then a write register with machine buffer register. See here, see here, we have taken the example like this: add to 176. So this data goes to the instruction register and this data goes to the machine buffer register. So adding of these two contents, instruction register and machine buffer register, store these whole data into instruction register. Okay. So write register, then write register plus machine buffer register and store in instruction register. Then instruction counter, hello, instruction counter is less than equal to instruction counter plus 1. Then again check machine buffer register is less than equal to instruction counter, otherwise stop. This is micro flowchart for add instruction. Did you get? समजलंय?
Yes.
Then machine structure of a 360 and 370. So whenever generating any machine, we should know the answers of the questions regarding memory, register, data, and instruction. In previous slide, we have seen that questions. So what is the memory? So you have
Yes,
studied,
sir.
hello, you have studied the concept of bit, byte, word. So what is a bit? There is bit is a binary digit. The memory space is required to store a binary digit 0 and 1 is known as a bit. Okay, मेमरी स्पेस 0 आणि 1 हे बायनरी डिजिट स्टोअर करायला जेवढी मेमरी लागते त्या जागेला किंवा तेवढ्या जागेसाठी तेवढ्या स्पेससाठी बीट कन्सिडर केलं जातं. बीट मेमरी स्पेस. सो वन बीट one byte is a length of 8 bit. 8 bit is equal to 1 byte. Then 2 byte is equal to half word. 2 byte is equal to half word. Then 4 byte is equal to 1 word. In case of half word, that is a 16 bit is equal to also known as half word. Similarly 32 bit is known as word, that is 4 bytes. And similarly double word, that is 64 bit, that is 8 byte, that is double word. So each accessible position of memory can be contain 8 bytes of information. So memory storage in the form of binary, that is in the form of bytes, and there are facilities to operate continuous bytes in basic units, and these basic units as given in the table. So combination of 4 bits. See here, suppose here, Okay, may I audible? Okay, see here. See here, there are 8 locations. So all this part, ह्या सगळ्या पार्टला आपण बाईट म्हणतो. Is known as byte. Then what is, याला काय नाव असेल एवढ्या पार्टला किंवा एवढ्या पार्टला? Byte is equal to 8 bit. 1 byte is equal to 8 bit. Then 4 bit is equal to what? 4 bit is equal to 1 nibble. 4 bit is equal to 1 nibble. Then word is equal to, one word is equal to 32 bit or 8 4 byte. Did you get?
Yes.
This 4 bytes is called as 1 nibble, or this is also 1 nibble. Okay, do you know the conversion of तुम्हाला बायनरी टू डेसिमल, हेक्साडेसिमल, ऑक्टल कन्वर्जन माहिती आहे? ऑल ऑफ यू, हॅलो. कन्वर्जन ऑफ डेसिमल टू बायनरी, बायनरी टू डेसिमल,
हो.
सगळं हेक्साडेसिमल, एकमेकाचे कन्वर्जन माहिती आहे तुम्हाला सगळ्याला. असं गृहीत धरून मी पुढे जातो. So unit of memory consisting 4 bits is sometimes referred as a nibble. Then the size of 360 machine, IBM 360 or 370 machine, the size of memory size of this 360 machine is up to 224 bytes. 1 minute. So the unit of memory consists of 4 bytes, sometimes known as nibble. And the size of the IBM 360 machine's memory is up to 224 bytes. Then addressing on the IBM 360 memory is consist of three components. Specifically, the value of address is equal to value of offset plus contents of base address plus contents of index register. Value of address is equal to contents of base register plus contents of index register. See here, value of address or this address number of particular address address of a number is equal to base address plus index address base address register base address register plus index address register. Index address register. Base value of address of a particular number which is stored in that memory. एखाद्या मेमरीला एखादा नंबर स्टोअर केला असेल तर त्याचा ऍड्रेस हा बेस रजिस्टर ऍड्रेस प्लस इंडेक्स रजिस्टर ऍड्रेस. समजा बेस रजिस्टर ऍड्रेस हा 2 असेल प्लस इंडेक्स रजिस्टर हा 176 असेल तर मेमरी ऍड्रेस हा 178 असणार आहे. Memory address is a combination of base address register plus index address register. It is a combination of both base address register plus index address register. So in general operations, units of memory are specified in low order byte address. When addressing a word that is 4 byte, the address of word that is a low order byte for the address of word starts from the low order byte. Then next part is a register. The IBM 360 machine has 16 general purpose registers. There are different 16 general purpose registers which consist of 32 bits each in addition and extra 32 bits for each general purpose registers. There are four floating points. There are four floating point registers, and that register consists of 64 bits. जनरल पर्पज रजिस्टर 16 आणि प्रत्येक रजिस्टर साठी 32 बिट मेमरी असणार आहे स्टोरेज कॅपॅसिटी. त्याच्यानंतर 4 फ्लोटिंग पॉइंट्स रजिस्टर्स असणार आहेत आणि प्रत्येक फ्लोटिंग पॉइंट रजिस्टर साठी 64 बिट मेमरी असणार आहे. देन प्रोग्राम स्टेटस वर्ड that is PSW that contains the value of location counter, protection information, and interrupt status. प्रोग्राम स्टेटस वर्ड्स मध्ये लोकेशन काउंटर असणार आहे, प्रोटेक्शन इन्फॉर्मेशन असणार आहे आणि इंटरप्ट स्टेटस असणार आहे. The general purpose register may be used for various arithmetic and logical operations as base registers. जनरल पर्पज रजिस्टरचा वापर हा बेस रजिस्टर म्हणून वेगवेगळ्या अरिथमॅटिक आणि लॉजिकल ऑपरेशन साठी केला जातो. When programmer uses them in arithmetic or logical operations, she will think these registers scratch pads to which numbers are added, subtracted, compared, and so forth. ज्यावेळेस प्रोग्राम लॉजिकल अँड अरिथमेटिक ऑपरेशन्स वापरले जातात त्यावेळेस ऍडिशन किंवा सबट्रॅक्शन किंवा कंपॅरिझन ऑफ टू नंबर्स किंवा कुठलंही ऑपरेशन करायचं असेल तर रजिस्टर हे वापरले जातात ॲज अ स्क्रॅच पॅड्स दॅट इज टेम्पररी स्टोअर्स. When used as base registers, they add the information of address. ज्यावेळेस बेस रजिस्टर म्हणून त्यांचा वापर केला जातो, देन त्यावेळेस त्यांचा ऍड्रेस हा मेमरीमध्ये स्टोअर केला जातो. द एक्झाम्पल इज हिअर. In this example, that is operation code offset is 1901. Then here 2 is index register and 15 is a base register. So here a number is a number is to be added to the contents of register. For this number a, here number a, it has offset 1901, then index register 2, base register is 15. So the location of the number is 1901 is offset, 1901 is offset plus contents of register 2 plus the contents of the register that is base register is 15. ह्या सगळ्याचं कॉम्बिनेशन जे काय असणार आहे ते ए नंबरचं लोकेशन असणार आहे, मेमरी लोकेशन असणार आहे. Memory location of a particular number which is stored at a particular register, it is the combination of offset, index register and base register. Base register, index register आणि offset या तिघांचा जो नंबर असणार आहे या नंबरची जी बेरीज येणार आहे सम, ही सम त्या पर्टिक्युलर नंबरचा मेमरी ऍड्रेस असणार आहे. So that is these three numbers were added together and result would be the address of memory location whose contents we want to add the contents of register 1. ओके, रजिस्टर 1 मध्ये आपल्याला हे स्टोअर करायचं असेल तर या तिन्हीची बेरीज करावं लागेल. ऑफसेट, इंडेक्स रजिस्टर आणि बेस रजिस्टर या तिन्हींची बेरीज जी काही येईल तो तुमचा मेमरी ऍड्रेस असणार आहे. सो वन मे आस्क, एखादा असा प्रश्न विचारू शकतो, सच कॉम्प्लेक्सिटी ऑफ फॉर्मेशन ऑफ ऍड्रेसिंग इज नेसेसरी. कॉम्प्लेक्सिटी, एवढी कॉम्प्लेक्सिटी ऍड्रेसिंगची गरजेची आहे का? So there are two reasons. First, the base register aids with the process of a relocation of the program. Base register हा जी प्रोसेस एक्झिक्यूट होणार आहे त्याच्या लोकेशनला असणार आहे. अँड सेकंड, the location of another by changing the contents of base register. We move from one series of location to another by changing the contents of base registers. Then major motivation for employing base register is, however, to promote efficient addressing of core. For the promotion of efficient addressing of code, that is, in minimum registers, we can solve these difficult problems with less time, with less registers. We can solve the complex problem. That's why there is a need of addition. Then here one example is given. See figures carefully. There are here 20 bits, 40 bits. Out of them, 8 bits for opcode, then 4 bits for argument register, 4 bits for index register, and 24 bits for addresses. Similarly, in another figure, there are 32 bits, 4 bits for 8 bits for opcode, 4 bits for argument registers, 4 bits for index register, 4 bits for base registers, and 12 bits for offsets. See both carefully. So in preceding add instruction, पाठीमागच्या आपण add instruction मध्ये बघितलं होतं, memory core as differentiated in following diagram. So for this we need total 40 bytes to store it, 8 bit for opcode, 4 bit for specify one of the 16 possible registers, that is argument registers, which are fetched from 16 possible registers, and additional 4 bits specify possible index registers. With these 4 bits registers are fetched from again 16 possible registers. Then lastly 24 bits specify address of number we want to add. If we use here total 40 bits, but if we use base register, we can store the instruction in following format also. Same instruction, here we have used 40 bits, but in following format we have used as 32 bits. So here we can store instruction in following format. We would specify any one of possible 16 registers as a base registers. Out of 4 bits, that is argument registers, 4 bits index registers, again 4 bits has taken from this address bit registers as a base registers. So out of these 24 bit registers we have removed 4 to move towards 4 to base registers, remaining 20. Out of 20 bits we have used 12 for offset, and 8 are and saving 8 bits per address reference. So address reference is a combination of offset, base, and index register. We have saved 8 bits from this address. Address requires 24 bits, but In previous example, we have seen for storage of any number to in memory, it is a combination of offset, a base and index registers. Here in first figure, they have given index register, but there is no base register and offset, which is by default stored here. So base register requires 4 bits and offset register requires 12 bits. So we can save 8 bits as per 8 bits per address reference, so that we can minimize the registers. So here the disadvantage of this shorter form are the overhead associated with the formation of address during the execution.
Hello.
झालं काय लेक्चर? सर
Hello. The disadvantage of this shorter form are overhead associated with formation of address during the execution of fact offset. ज्यावेळेस ऑफसेटचं एक्झिक्युशन येईल त्यावेळेस हा बेस ऍड्रेस कॉम्बिनेशन झालेलं असणार आहे आणि ज्यावेळेस ऑफसेटच्या एक्झिक्युशनला असणार आहे त्यावेळेस 12 बीट हे खूप मोठे असणार आहेत. कॅन बी स्पेसिफाय नंबर फ्रॉम 0 to 4095, that is total number of 4096. So it may be difficult to reach this data, that is without using index register and without changing contents of base register. Without using this index register, without changing this base register, the core location we want to address cannot be further than 4095 locations away from the core location. So if we are, so this is the disadvantage for using this shorter form. In case of addresses, whenever there is execution, only offset execution is done, then it may be vary from 0 to 4095. So index register is 4 bits, base register is 4 bits, but the cursor or memory address is vary from 0 to 4095. So it is difficult to reach that point to prepare a particular address. Okay, this is a diagram for a data. We will see in next lecture. Okay, hello. Due to some work, I am unable to conduct this lecture onwards. So we will see on Tuesday. It's okay.
Okay, sir.
समजलं नसेल तर विचारा. आतापर्यंत शिकवलेलं समजलेलं आहे का?
सर रेकॉर्डेड लेक्चर सेंड करा ग्रुपवर.
रेकॉर्डेड कसं होतंय, आता जे बोलतोय ना आपण ते सुद्धा रेकॉर्डेडच होत जातंय मॅडम. तुम्हाला वाटल्यास पीपीटी सेंड करतो. ओके
सर आवाज व्यवस्थित येत नाही.
ओके सर.
बरोबर. आवाज एक व्यवस्थित येत नाही का? हॅलो.
हा सर.
ओके ओके ठीक आहे. नेक्स्ट लेक्चर पासून व्यवस्थित केला जाईल. आणि तुमचे आता रोल नंबर लिहा आणि सेशन लॉग आउट होऊ शकता. ओके.
रोल नंबर सांगूया सर.
रोल नंबर सांगता का? चालेल की.
हा
चॅट बॉक्स मध्ये लिहा वाटल्यास.
सांगतोय घ्या.
सांगा, एक मिनिट.